All right. Hello, everyone. Welcome to the McDonald Observatory presents Family Astronomy, Life of Stars. I'm Martinique Pautsky. I'm the K-12 Education Program Coordinator for Student Experiences at the McDonald Observatory. So I get to facilitate student field trips and public programs. We also do virtual stuff. So lots of fun stuff. Joining me tonight is one of my colleagues, Dr. Judy Meier.
Am I supposed to say something now?
If you'd like to.
Okay, I'm Judy Meier. I am also a K-12 Education Program Coordinator, and I specialize in the teacher professional development, but I get to work with teachers and students and people who come to visit. So it's great to have all of you here, and I'm seeing lots of folks saying they're here, so this is great.
Woo! Yay. Another person joining us is very important tonight. So, Rivera, what are you doing?
Yeah, so my name is Saul Rivera. I do more of the public programs, the tours and stuff. And tonight I'm running the telescope that we'll be looking through. So you can see a bit of the gleam of the telescope behind me.
Sparkles in the moonlight. Although we don't have moonlight, starlight. Yeah, Saul's super important tonight because he is the one that is getting us the live views. A few other people we have are our moderators in the chats. Please drop your questions as we go. Sometimes they'll be able to answer them just right in there. Sometimes they'll sneak them aside and present them to me and Judy and Saul at the end. So go ahead, drop them in as you think of them, and we'll do what we can to get to all of those. The first thing I need to know, though, is two things. One, where are you from? And two, how old are you? Or if you're an adult typing and you have a younger astronomer in the room, tell us how old they are. You can tell us how old you are, too, if you want. But I want to know, where are y'all from? What grades are we talking to here? Got some Central Texas. Hello, Arizona. Got some kids are excited. Austin. Always seeing some Austin in here. South Texas.
Oh, somebody's 13.
13. Hello.
Wow, I certainly would not know how to say your name. It's beautiful, but I wouldn't know how to say it. Pennsylvania, and 8. Wow.
Wonderful.
Oh, Joan, thank you for being here, Joan. I'm guessing you're not 7 and 8.
10-year-old twins and Andrews. 51 from New Mexico. Hello, Mark. 69 years young. 78. Joan, welcome.
I see a 2.5-year-old.
Oh,
start them young.
Mm-hmm. Dallas, 63. El Paso, 75. Oh, I love this. 43, 12, and 6 from Austin. Hello, Oklahoma. Oh my gosh, this is so much fun. Keep them coming. I love this. Well, welcome, everyone. If you joined us for our family astronomy session that we did in December, you would have learned a little bit more about where we're at in far west Texas. We talked about a little bit what we've got here at the McDonald Observatory. We showed off the telescope behind Saul a little bit more. We had a little more lights at that program. And that program was about planets. So we showed off a couple of live planets. And the planets that we looked at were inside of our solar system. Tonight's program, The Life of Stars, we're going to be looking at something called deep space objects. So these are objects that are outside of our solar system, right? Outside of our planets around our sun. But all the objects that we will be looking at are outside our solar system, but inside our galaxy. Does anyone know the name of our galaxy? Can you type that in the chat? It's the name of our home galaxy. Judy knows. Don't give it away, Judy. I'm going to keep talking while y'all are typing. So if you know what a galaxy is, you know that it is huge, all right? If you think of a galaxy compared to our solar system has our sun with our planets orbiting around it. A galaxy has hundreds of billions of suns, stars, orbiting all together around that center mass. And that huge collection of hundreds of billions of stars is called the Milky Way. Thank you, everyone. Look at you go. I'm just going to grab one here. Thank you. It's called the Milky Way, and that's because kind of looking up in the sky, it looks like this little milky thing across the sky. Thank you, everyone. Y'all got it. So what we're going to be looking at are objects still in our galaxy. And the first thing that we're going to talk about when we're talking about the life of stars is how stars form. I'm going to toss this over to Judy.
Oh, yay. Okay. So here come my slides. And where are my slides? Okay, there they are. So this is not a picture of stars. This is a picture of people. And here's what I want you to imagine. Imagine that you are a space alien. You're from another planet. And you land on the Earth. And you have 2 hours to learn everything there is about humans. So you land on the Earth. You see a whole lot of humans. And maybe you'll just take a lot of snapshots. And then go back home to your planet and see if you can figure out what's going on with these snapshots. So if you took a whole lot of snapshots of humans, do you think you could put them in order and figure out what a human was like and how a human's life went? I think maybe you could, but let's see what our space alien did. Yeah, they lined up the humans, and you start with young ones, and they're maybe littler, and then they get bigger, and then when something else happens, when they get older. So that's what I would do, and that's kind of what astronomers do with stars. So we've taken a lot of pictures of stuff in space, and we're just trying, and they're like snapshots of humans, and we're just trying to figure out what it is that's going on. And so the first thing we're going to look at is a place where stars are forming. And so let's go there. And where we're going to go is what's called the Orion Nebula. And Saul is going to stick the picture up on the screen for us. Maybe there. There it is. So this is the Orion Nebula. And so there's a couple of words I want you to learn, and one of them is nebula. Nebula is a funny word. It's a fancy word for a cloud of gas in space. And I've got, there's our banner that says nebula, so you can see the word on your screen. So there's a cloud in there. Do you see the cloud, right? And there are some stars. You can see stars, and you can see a cloud. And what's happening in there is, well, it's a big cloud of gas in space, and that cloud is not smooth and calm. That cloud is, the word that we're going to use for that cloud is turbulent. Things are moving around inside that cloud, and sometimes the gas in that cloud gets a little closer together, and if it gets a little closer together, it has a little more mass in one place. And if it has more mass in one place, then it has a little more gravity. So the next word I want to talk about is gravity. Gravity. So I'm holding my pencil here, and if I let go of my pencil, I bet you all know what would happen. You all know what would happen? I let go of my pencil, it's going to drop, right? So that's because of gravity. And it turns out everything that has mass, like this pencil, has gravity. It's just that this pencil doesn't have nearly as much mass as the Earth does. And so the two things that have mass are attracted to each other, and mainly the lighter thing is attracted toward the more massive thing. Inside a cloud like this, there's a little knot of gases that's got more mass than the stuff around it, so it's the one with the gravity that wins, and so more of the gas goes in there. And eventually, there's enough gas that inside that cloud, the atoms on those gas can fuse together. And that's a process called nuclear fusion. So there's a lot of stuff happening there in that cloud. And nuclear fusion is one of those things. And nuclear fusion takes two atoms, well, actually more than two, but we'll say two atoms, puts them together and forms a whole new kind of atom, and that makes energy happen. So nuclear fusion makes energy happen. And this is a beautiful picture from our telescope there's some young stars in there. You can see the young stars, but there's also some dark clouds. And inside those dark clouds, gravity is happening and the gases are coming together and more stars are forming. So I'm going to switch over and show you some more slides, because more stars are forming, and I hope, yeah, that's my next slide. And so here's where we're looking. We're looking in the sky, and I know when you look in the sky, you do not see little green lines connecting the dots, right? I just have those lines in there to help us find the patterns. The pattern we're looking for tonight is the pattern of Orion. Orion is kind of shaped like an hourglass, and we see Orion's belt, we see Orion's sword, and we are looking, yeah, there's a picture of a hunter. Orion is supposed to be a hunter, and we are looking right in the middle of his sword. So here is a beautiful picture that comes from the Hubble Space Telescope of the Orion Nebula. And it looks different from our live picture, right? Well, there's a couple things the Hubble Space Telescope has as its advantage. One is it's in space, so it doesn't have to worry about the Earth's atmosphere, whether it's dark outside yet or not, stuff like that. The other is that it can take a very long picture, take a long time to take a picture, and it uses advanced technology to come up with a picture that shows us colors. Now you see colors here. There's some pink, right? And we get pink because hydrogen is glowing and hydrogen glows pink. And then there's brightness in the middle, and that's just because those young stars are very, very bright. We've got these dark clouds here, and inside those dark clouds, gee, I wish we could see inside those dark clouds. Astronomers have a pretty good idea what shape the Orion Nebula is. We think those young stars are so energetic that energy has kind of blasted those clouds away from the middle, and the Orion Nebula is shaped a little bit like a bowl. So I think we get to fly through it, maybe. Nope, this is the wrong video. This is the video that shows us into the clouds. Sorry about that. I thought we were going to go for a flight through space, but no, we're going to look through the clouds. So these are dark clouds, and we can't see if there are stars inside them. But if we could detect light that was infrared light, then that infrared light can pass through those dark clouds. So there is a telescope in space that does that, and that's the Spitzer Space Telescope. So we're just gonna go from the visible light view of the Orion Nebula to the infrared view. Here we go. I have to zoom in a little bit, and we're gonna switch telescopes here. And suddenly those dark clouds are sort of clear, and you see a whole lot more little tiny stars, because those little tiny stars were hiding behind the clouds that we couldn't see before. So there's a beautiful view looking at all those stars, and they all formed from this huge cloud of gases. And there they are in the Orion Nebula. Wow, I just think this is so pretty. This is one of my favorite things to look at with a telescope, and I really hope you could look at it with a telescope. If you're somewhere where you can find the constellation Orion, point your binoculars at Orion and see what you can see. All right, so once you have a bunch of stars in one place, they form from one big cloud of gases. Well, then you have a bunch of stars in one place, and what we call that is we call it a star cluster. So here are a whole lot of pictures of this kind of star cluster. These are called open star clusters. These are young stars, and this is kind of a mosaic. It's a whole bunch of different pictures of open star clusters. And aren't they just pretty? Young stars. And these stars were actually kind of hiding in a cloud. It took a special sort of telescope to find these particular stars. But we are going to look at a star cluster that's in this same area of the sky. So we had Orion here looking like an hourglass, but just over to Orion's left, there's this constellation that is Gemini. And Gemini is supposed to be twins. So you see two figures sort of standing close together because they're twins. And the star cluster we're going to look at is down by the feet of one of the twins, right down there. So we circled it in red there. That's where we're going to go to find this star cluster. Now, our star cluster does not have a cute name. It's called Messier 35. I know that's kind of boring. Usually we call it M35 just because that's a little easier to say. But let's see. Saul, are you ready to show us your view of that? Oh, there we go. So that's a whole lot of stars. They're all in one place because they were formed from one huge cloud of gases. And so there they all are. Now, stars, when they're young, they're often very hot, very bright, very sparkly, very blue, very, very, very pretty. And so this is M35. It's really fun to look at through a telescope because these stars are very twinkly and bright and pretty. And I love that. I love that. So after we've started doing nuclear fusion in the core of the star, then the star becomes what we call like a full-fledged star. And we usually say it's not forming anymore, it's all formed. And I'm going to switch over and show you some other pictures of M35 while Saul goes to our next target. So let's just go back to my slides. There's a beautiful picture of M35. See how bright and blue most of those stars are? They're very young. But what's happening there is what we call, this is my favorite set of words in astronomy, hydrostatic equilibrium. So gravity is pulling these stars inward because there's a lot of mass, so the gases are being pulled inward, and nuclear fusion is happening in the inside, pushing outwards, and that's in balance. So equilibrium means balance, and hydrostatic means these gases. So the inward and the outward are in balance, and the star does its main lifetime thing. So our sun is in hydrostatic equilibrium, and most of these stars you see in this beautiful picture are in hydrostatic equilibrium. But turns out with this cluster, it's very close in the sky to another cluster. Just back up a little bit. See that little cluster of other stars? That's another cluster of stars. They're still pretty young, but they're older than the stars of M35. And they're farther away. They look smaller, and they're not as blue anymore. Blue stars are often very, very hot, and they burn themselves out fast. And so this smaller cluster is finished having blue stars. It's just doing its main thing, doing other things. So we have a bunch of stars, and I think that's my last slide. So Martinique, do you want to tell us what happens next? I'm very interested.
Yes.
Yay.
Let me. All right. So at one point, those stars will run out of their fuel, right? The fusion that Judy was talking about, that's fusing hydrogen into helium and heavier elements. And at one point, you run out of those elements that you need to fuse into those heavier elements. And just like your car can run out of gas, a baker can run out of flour. When that star runs out of fuel, that fusion will stop. And when fusion stops, right, if the fusion is what's causing that outward push, and the outward push stops, the outer layers will start being pulled in by that gravity, by that strong gravity. So a few different things can happen when a star ends their life, and it depends on how massive that star is, right? Supermassive stars have a lot of stuff. They're really heavy, they're big, and a smaller mass star is just a little less, right? Less gravity, less mass there. So the first one we're going to talk about is if there's less mass there. So kind of like a sun-like star. A sun-like star, when it ends its life, the final stages, it starts puffing out its outer layer of gases as it's finishing up using that fuel. Do y'all remember what we call a cloud of gas in space? Do you remember that word? Judy remembers. There's like a delay. I know y'all are saying it, right? That is a cloud in space, is a nebula. So the cloud in space that we're going to look at next is a planetary nebula, and it has nothing to do with planets. All right, I'm going to see if you can figure out why we call it a planetary nebula. First, let me show you where we're looking in the sky. Here's a similar map to Judy. Y'all can see, sorry, down here is Gemini, and that little green circle is where we're going to be looking at our next target. And this next target is ready to go. So I'm going to pull up our view from Saul here. There we go. So this is our planetary nebula. Now, y'all make some observations in the chat. What does this look like to you? Give me some describing words. Planetary nebula is what it's called. That's the type of object. But it's, you know, what do you got? It's kind of spherical, kind of cloudy, right? That's how we talked about nebula are like clouds in space. You can kind of see in this image really, really well why planetary nebula was the term that was coined for this. It's because it's kind of spherical. If you watch our live stream from December and we looked at those planets, they're just round disks. And planetary nebula often look like a nice round circle. So they kind of looked like planets in those earlier telescopes. So they called them planetary nebula, but they have nothing to do with planets. So it's just a name that stuck. So this planetary nebula, this one is NGC 2392. And I wonder if y'all can come up with a better name than that. NGC 2392, that's the new general catalog. And that's the catalog number. So not very exciting. Some things in space have a fun name. And the best one that I've heard for this, I hope y'all are going to type something fun in the chat. But the best one that I've heard for this one is the Lion Nebula. And it's because it's kind of got a mane there. I really like that one. But I'm hoping y'all drop some other fun names. We always like to hear what people come up with. Just looking at what y'all are saying. All right, we'll look for some fun names here. This object is about 5,000 light years away. Like we said, it's in the direction of Gemini. And the diameter of it, like the width that we're looking at there, it's almost like 2 trillion miles across. And because trillions of miles are kind of hard to define and think about, astronomers use light years. And a light year is the distance that light can go in a year. And because light travels really, really fast, it can go really, really far in a year. It goes about 6 trillion miles. So 1 light year is about 6 trillion miles. So this object is about 0.3 light years across. So kind of small, but I mean, that's a couple trillion miles. So not small. Let's see. Just scanning through my notes. I don't want to miss anything. Do y'all see? All right, we got to see something there in the middle. Do y'all see a bright spot in the middle? That bright spot, that is the star. That's the star that was letting off those gases. And it's still really, really hot. So it's still bright. Even when it stops fusion, it will continue to glow because of how hot it is. Even though it's not creating more heat and energy, it's still going to stay hot for a very long time. And it's going to be a white dwarf until it dims so much as it cools that we don't see it anymore. And once we don't see it, then we'll call it a black dwarf. Scrolling through some names, we got the Eyeballa, like nebula, Eyeballa. Dandelion is good. I like that one. Circle Nebula. It is a circle. Eyeball Nebula. That's a good one. The Leo Nebula. Y'all are great. So this is our planetary nebula with that singular white dwarf in the center. I'm going to show you a few different images here while Saul moves our telescope for me. I want to show you another picture that was taken not with an Earth-based telescope, right? The telescope we're using today is about 16 inches in diameter. It sits on our planet inside our dome, just down by the visitor center. But some telescopes are out in space. Judy talked about the Spitzer telescope. Y'all have probably heard of the Hubble telescope. Now, this is the Hubble Space Telescope. It's just a beautiful picture. But being up in space, this telescope doesn't have to look through air, which can scatter light around. It can stay pointed at an object for a long time to collect a lot of light, and it's got some really great instruments on it. So the Hubble can take amazing photos like this one. This is a Hubble image of NGC 2392. Or the Lion Nebula, or I like the Dandelion Nebula. I really like that one. We might have to start using that at the visitor center. But this is an image of that nebula from a space telescope. You'll also notice there's color in this image. Our telescope at the visitor center right now is using a camera that's just in black and white. And that's because it's easier for our eyes to see things when they're just in black and white. If we did a longer exposure at different wavelengths, we could simulate some color in there. And that's often what telescopes are doing, is they're collecting light at different wavelengths, and then they're putting them together, stacking images. And that's what this sort of image is. It's just gorgeous. So this sort of planetary nebula is what happens at the end of a star's life if it's a lower mass star. And somebody asked earlier, Bodster W, what age do stars die? And a low mass star can last for a long time, tens of billions of years. And a white dwarf will cool for hundreds of billions of years. Now, if the universe is about 14 billion years old, we haven't seen those old of stars at this point. We need to wait for some more time to pass. But if a star was much more massive, lots of mass, lots of gravity pulling in, lots of pressure pushing out, if it's a higher mass star, it's going to burn through its fuel much faster. It will not live for tens of billions of years and glow for hundreds of billions of years after that. A high mass star is going to finish its life off in a much shorter time period. The next object that we are going to look at is up in Taurus. Let me grab it here. So still just above Orion there, we're looking at Taurus the Bull. I just need to stop trying to point at things. Under that circled area is where we're going next. And what we're going to be looking at is an object called M1. Messier 1 is a supernova remnant. It's another type of nebula because it still looks like a cloud of gas and dust in space. So it's still a nebula, but this one is a supernova remnant. And that is a word that y'all might have heard before. Have you all heard supernova? Can you, if you're in a room with other people, can you turn to someone and show me on your hands what a supernova could look like? You just take a second to show someone what you think that word looks like. A lot of people, when they think supernova, they think a huge explosion, right? And that's not wrong. A supernova is like a huge explosion in space. But first, there's an implosion. So explosion isn't the whole story. What happens when that super massive star stops fusion, right? The fusion is that outward pressure. When the outward pressure stops on a very massive star, all of that mass with so much gravity gets pulled in really fast. And a lot of stuff pulling in really, really fast creates a huge amount of pressure at the center. And that huge amount of pressure fuses things together to the point where we create a neutron star, just neutrons. And once things get crushed together as much as they can, all the other stuff that's still coming in bounces off of that. And that is when you get that explosive force, that force of all of the stuff shooting back out into a huge cloud in space. And that's what happened to the object we're about to look at. M1, which is where we're going next, went supernova. It was a supermassive star that went supernova in 1054. It was actually observed by Chinese astronomers and others. We found records later on from Japanese astronomers and even Islamic records. So a lot of different cultures saw this guest star, is what they called it. It was bright enough to be able to see it in the daytime. So they saw this star, and 1,000 years later, when we developed telescopes, astronomers found a little cloud in space. So we're seeing the aftermath of what that M1 supernova did. And let's see it. Saul is ready. I'm going to add it to the chat here at the screen. And this is the Crab Nebula, M1. What do you all think? Put some words in there for me. What does this look like to you? Does it look like a crab? The Crab Nebula, maybe you guys can come up with better words. Dandelion was great. I need my dandelion person to come up with something good. They call it the Crab Nebula because one of those earliest sketches, goodness, was it William Herschel? It wasn't. Rachel might know. She'll put it in the chat. She knows many things. Judy might know. But the one of the earliest sketches of an astronomer who was looking through a telescope years ago, drew a little sketch while they were looking. And when they looked down, it looked kind of like a crab. So they called it the Crab Nebula. And that stuck. Even though looking there, it might not quite look like a crab. Smoke. Yep, it looks a bit like smoke. A brain. Oh, that's so true. Or cloud. Yep, an eye nebula. Yeah, tumbleweed. That's a really good one. Are you in Texas, Sarah? Tumbleweed is a great name for a Texan to come up with. But it does. It really does. So that cloud of gas is still expanding from that supernova that happened in 1054. And that cloud of gas is expanding at the rate of 930 miles per second. I did some math earlier, and that's like over 3 million miles per hour. And that doesn't seem right to me. That's crazy fast. And because it's moving so fast, we've actually picked up on some of that motion. A lot of things in space happen so slowly because they're so far away and timescales are huge that we can't actually see things changing all the time. If you looked at the Crab Nebula every single day your whole life, you probably aren't going to notice anything different. But while Saul points to our next object, I'm going to show you a little video of pictures that were taken of the Crab Nebula over a few months, right? I think this is September to November. And you can see these images. You can see that cloud of gas is still expanding. There's motion in there. So this supernova that happened almost 1,000 years ago still has stuff moving out. Did the event happen in one day? Suzette asks. I don't know how long it took to dim again. I know that it was recorded being seen on July 4th in 1054. Most of the time, supernovas take weeks to dim. Maybe Judy can nod her head. Did it take weeks, months? Yeah, weeks or months for these supernova to dim out. Thank you for that question. That was a good question. It's about 2 weeks was the length. Thank you, Saul. Yeah, so just a couple of weeks. Oh, yes. Thank you, Saul. This was the last one. Good call. This is the last object I get to show you. But this is that video showing that activity. Now, what is still left in the center, right? After that star went supernova, I mentioned that what's left behind is a neutron star, super, super massive, but very dense. Imagine taking the mass of the sun and smushing it down into the size of the city of Chicago. Like, that seems impossible, but that's how tightly packed things are and how heavy things are. Like, do you think you could lift up your house? Like, you could pick up your house and smash it into a tiny ball. Even if it's small, you still can't pick it up. It's as heavy as your house. That's what happens with these supernovas. They crush so much mass into such a small space that it's so dense and it's spinning so fast. This neutron star is actually spinning about 30 times a second. Super, super fast. And its diameter is like 18 miles across. Not that big, size of a city. Something else that can happen at the end of a very massive star's life is after that supernova, as everything's coming together, if that amount of gravity is so strong that even the after effects of the supernova that would push everything back out, if the gravity is so strong that it holds everything together that not even light can escape, something else forms. We don't get a neutron star. Drop in the chat, guys. What am I talking about? What is something that has such a strong gravitational pull that not even light can escape it? Black hole. And that's the end of our program, guys. Bye, everyone. No, people love black holes. That's actually why I didn't say at the beginning. Somebody asked if there was a supermassive black hole at the center of our galaxy. And yes, most massive galaxies have a black hole at the center. But a single star that's massive enough can collapse into its own little black hole. So that can be another end to a star's life. Y'all, I've seen all the black holes. Good job, everyone. I do want to quick show you, there was a picture taken of a black hole. Now, not exactly, right? Because if light can't escape, because the gravity is too strong, that the light can't even move fast enough to get out of that gravitational pull, you can't actually take a picture of something that there's no light, right? So it's not exactly the picture of a black hole. It's the picture of the warm stuff orbiting around it. All the gases and dust that are orbiting around this black hole so fast started to heat up that this image was able to be taken of a black hole at the center of a galaxy. So this just happened a few years ago. So very, very awesome. But now is about the time that we need to be getting some of those questions in the chat. We need to be getting some answers to y'all. Sorry, Judy, I'm bringing you back in. So welcome, good. Judy, you're muted. Somebody started, I think one of the first questions that our mod grabbed was, how long do stars live? And it depends, right? The super massive ones burn through their fuel really, really fast, like a rock star, right? They live their life fast and hard. They're done real quick. So that's a couple millions of years. And the low mass ones that take a lot of time fusing just can live for a very, very long time. Billions, hundreds of billions. We got time. Yeah.
Mm-hmm. Okay, so I'm just gonna pick a question. And one of the questions I'm gonna pick this question from Arunka 007. How do scientists know about all this? Scientists pay a lot of attention to what they are observing, and they've observed a lot of different things. One way they learn about things, especially stuff that's far away in space, you can look at stuff with your telescope and see it looks like a cloud, and that's okay, but it's kind of doesn't tell you everything. But if you can take that light from space and spread it into the colors that make it up, you can learn what chemicals make it up. You can learn how it's moving. You can learn about its magnetic field. You can learn all kinds of things by studying the light from stars. So most of the astronomers at McDonald Observatory don't just look at pretty pictures. They are taking the light that they collect from stars and they're analyzing it. And that's how they learn it. Okay, I'm picking the next question. And the next question is, how cold is Seoul right now?
Yeah, it's about a high 30s in the dome right now. So actually kind of warm compared to how it's been, like especially like last week.
Okay. Sarah says, have you seen the movie Don't Look Up? I have not.
I have not
either. I've seen the trailers and I've heard good things about it.
Well, we're really boring here. Maybe we were working or something.
I've heard it's about astronomers, so we're supposed to watch it.
Yeah. Have we ever observed a comet in the telescope? This says comet, not comment.
Not this telescope. I don't think so. But some of the smaller ones.
Mm-hmm.
Mm-hmm.
Yeah. Ooh, here's a question from Maisvel Palmer. Can you predict when the supernova will occur? So the answer will kind of be yes and no. So we can see a star, be like it's reaching the end of its life. We know the star will be a supernova. But when that actually happens, a big leeway. So a good example is the star Betelgeuse in the Orion constellation. Don't say the name 3 times, bad things may happen. That star is set to blow up literally any second. Let's see, I can see it from here. Or within the next 100,000 years. So we got a good leeway going on. So we know it's going to blow up. We know once it does, or maybe it already did blow up, the light will be so bright, it will outshine the moon for about a month. But when exactly that will happen, we're just have a very long range going on.
Timescales in space. Somebody asked, why do stars seem to twinkle? So that is that starlight traveling through our air. Air kind of bends and wiggles light around a little bit. So when that pinprick of light traveling through space gets moved and wiggled a little bit, our eyes pick up on that and it looks like a twinkle. Just like if you're swimming at the bottom of a pool, you can see kind of the light getting wiggled around. Similar kind of thing. So clear images happen if you go to space to look up. So, highly recommend.
Okay, I don't know where the question went, but somebody asked how far away is the Crab Nebula. Do you have that answer in your head, Martinique? Because I just looked it up.
6,200.
It's about 6,500 light years.
Yes.
Yeah. So what that means is the supernova was observed going off in 1054, but really the light reached the Earth in 1054, and the explosion happened 6,500 years before that. And it took 6,500 years for the light to reach the Earth. Yeah.
Very good, Judy. We've got another question. Vivian wants to know, how many galaxies do we know about and how many stars have we counted so far? Oh, Vivian, big numbers here. So our galaxy, just the Milky Way, has a couple 100 billion stars in it. And with our telescopes, we've seen tens of billions of galaxies, each one having lots of stars in them. Great question.
Mm-hmm. So we've seen tens of billions of galaxies, but how many are there really? Oh.
We can only see, about 14 billion light years away from us because that's how much time we've had for the light to get here. So wait a couple more billion years and we'll be able to see a little farther. Might pick up a few more.
Yeah.
Judy, why don't we see light rays between stars? Or why is the sky black between the stars?
Oh, I always forget that answer. Saul, why is the sky black between the stars?
The reason the sky's black between the stars. I used to know this answer. It was a homework question when I was in school. I can't remember. I want to say it's the way the photons are, because it's not really just like, just a straight beam, but like we see is photons. So lots of little bitty parts that are just scattering around. Like for me, I'm inside the dome right now. I have the screen right now. That's kind of what's part of the light. The reason you can kind of see me, apart from it being an infrared camera. But the telescope's so dark, and the walls are so dark. If the light kept on going there, it would kind of show evenly. I think I'm probably just making this way more complicated.
Okay.
Short answer, I don't remember that much, but I think it has to do with it being photons of light.
See, the questions that sound the simplest are usually the hardest. I'm looking at them. There's the one from Adam Peralta. Have you seen signs of alien life? No.
Yeah.
No. We're looking for things, but
astronomers are looking up all the time, and they're the least likely kind of person to be submitting views of UFOs and extraterrestrials or anything exciting, because we know what we're looking at.
Okay, I found one I can answer. Cyclops says, how many constellations have you found? All right, so here's the deal. A constellation is just a pattern of stars in the sky that's been set up by, there are 88 official constellations that have been set up by the International Astronomical Union, but anybody can find a pattern of stars in the sky and call it whatever they want and tell a story about it. And so there are 88 official constellations, and there are as many as you want there to be.
Just connect the dots. Bodster asked, how many stars are visible in the night sky? It's about 6,000, 7,000 our eyes can see. Yeah, our eyes only pick up so much light. But if your eyeballs were like the size of a 16-inch telescope, you could see way more. So highly recommend evolving bigger eyeballs.
I found another one from Cyclops. What is inside a black hole? So we do not know. There are many theories of what could be inside the black hole, but we honestly don't know what's actually inside.
Mass.
Yeah. Mass,
There's
gravity,
mass
light
there.
being bent. That's about it.
Mars fell. So you should answer this. How did you become an astronomer, and where do you start?
Oh yeah. So if you want to be an astronomer, so with astronomy, so some people are amateur astronomers. They do astronomy as a hobby, kind of just learn more about space on their own. Really good thing is if you just want to be an amateur astronomer, look around with a telescope. Good thing is to learn the night sky, like the constellations. They're kind of like maps for the astronomers. If you want to go into astronomy more seriously as like a career, it'll be good to go to a university. So I, for example, went to UT Austin, Hookham, and I'm obligated to say it since they're also my bosses technically, all the way back in Austin. But it's a very good astronomy program. But there's lots of courses going into the science and the math. And also for astronomy, you can say there are 3 routes. The routes of the researchers, the ones who are getting the data, coming up with the theories, all this and that, what someone usually thinks of. There's also the engineers, though. The engineers with backgrounds in astronomy or like astronomy build the telescopes, build the instruments. Well, that's the other astronomers actually find out stuff about space. And then there are those who like the teaching aspect. So people work at museums, such as us here at the Visitor Center, and similar stuff like that. So you can definitely become an astronomer in your own time, an amateur astronomer. Amateur astronomers have also made discoveries, so that's not an exclude. You don't have to be a professional to do that. And if you want to be more serious, well, going into learning and seeing which aspect you like the most.
Mhm.
All right, y'all, I think we should take one more question. Alba asks, why did Pluto stop being considered a planet? Did we talk about that in our December live stream, I think? Y'all, you look, go to our December live stream. I'm pretty sure I talked about it because we were talking about planets and everyone gets all salty. Pluto is the king of dwarf planets now. Everyone loves Pluto. I'm gonna throw one more at you, Saul. Or Judy, what do you expect the Webb telescope, the James Webb telescope, to find that we've never seen before?
Oh, the James Webb Space Telescope is going to get a view of galaxies that were some of the very first things formed after the Big Bang. And that's exciting. We don't know what they're going to be like.
Oh.
Yep.
All right.
A good beginner telescope to start with. One more answer. Good beginner telescope to start with. Binoculars. All right.
So true. Y'all, we love your question. Judy, do you want to answer one more?
No.
The questions are the best part. We love them. We're going to be wrapping up here, though. We want to let y'all know before you go, we've got public programs going on. We always recommend you make reservations. They sell out. Guided tours of the research telescopes, star parties at night to look through telescopes. Our education programs, we're pretty busy in the K-12 department. We've got field trips starting up here soon with students coming out to see those research telescopes. We do virtual visits, so programs a bit like this will come into your classroom virtually. And Judy, what else do we do?
What?
Teacher workshop.
I'm like, teacher professional development. We're doing 4 teacher workshops this summer. You can learn about them on our website, and we've got some virtual options that are coming up as well. So, yay. If you're a teacher, connect with us.
And also, we have done other live streams. I saw some of y'all said in the comments say this was your first one, so thank you for joining on in. But you can find our past live streams on this YouTube channel, and you can find them, and they go from more K-12 stuff to the moon to galaxies, lots of variety there.
Yep.
Lots of stuff. So find us on your social media places, like, follow, and subscribe to see those announcements when we're doing more in the future. And for other ways to support us, you can find our website. We've got a friends group of the observatory, as well as a fabulous gift shop to buy presents for people.
Yes. So thank you all so much. This has been fun. And
thanks for
tell your
coming.
friends. We'll see you later. Bye.
Bye.
Bye.